get them copied down, the better off for everybody.
Okay, my question.
What?
87.4. If you're rounding to nearest degree, still 87, right?
Alright, so find the sum of the interior angles of a convex polygon. Remember a convex polygon? Convex polygon is one of the normal polygons, like on that poster up there. A concave polygon, which we're not going to deal with because they don't fit the formulas, is one where it's got that one crazy angle that turns in. So it could be something like that. It could be something like plus sign or something like that. That's a concave polygon. We're not going to deal with those because they don't fit the formula. So you're finding the sum of the interior angles. That means all the angles added up. You already know one of them. For a triangle, the sum of the interior angles is what? 180. So you already know that one, and we're going to find the others. Also be able to find the sum of the exterior angles. Where most of you are going to get messed up on these problems is because you got to read the problem carefully. If it says find the sum of the interior angles, you use one formula. If it says find the sum of the exterior angles, you use another formula. And then if it says find the measure of each interior angle, you use a different formula. Find the sum of the measures of each exterior angle, you use a different formula. So there's 4 different formulas. All right? And you got to read the problem carefully so you know which answer or which thing you're looking for. Notice on these last two, it's got to be a regular polygon. Anybody remember what a regular polygon is? Those are regular, most of them. Regular polygon we'll talk about here in a minute. And if you don't remember, we talked about earlier in the year, but regular is a special.
Same side measures, like angles and same side.
And we'll write that down here in a minute. All right, on this, don't write this down, just follow along where this formula comes from. If I pick this vertex of this hexagon here, and I connect it to that vertex, what did I just form right here? Triangle. What do you know about the 3 angles of a triangle? They add up to 180. If I connect that same vertex to there, what did I just form right there? Another triangle. That's got to be 180. If I connect this to that vertex, that's another 180, and this is another 180, right? Did I create any new angles there? No, all I did was took the old angles and split them up into smaller parts, right? So I didn't create any new angles. So all the angles that were here originally have to come from that total. Well, I just take 180 times 4. That ends up being 720. So what do you know about all 6 angles in this hexagon? They add up to 720 degrees. And that's what it's going to do. We could do the same thing on this octagon over here. I'm not going to. Let's do the quadrilateral here. I connect this vertex to every other vertex. How many times am I going to draw lines in here? 1. How many triangles do I have? 2. What's 2 times 180? 360. What do you know about the 4 angles of every quadrilateral in the world then? They add up to 360. All right? We could do the same thing over here. If I pick this vertex, connect it there, connect it there, connect it there, connect it there, connect it there. 1, 2, 3, 4, 5, 6 triangles, 6 times 180. That would tell you what the interior angles of an octagon always have to add up to be. We're not going to have to do all that. Remember, these are called diagonals too. Each one of those is a diagonal. We're not going to do all that because they're going to give us the formula, and we're just going to use the formula to find each answer. The other thing I want to say before I go on, this angle right here, does anybody remember what's that angle called? These are on the insides, so they're called interior angle. What's these called?
Exterior.
Exterior angles. How many exterior angles is this hexagon going to have?
1, 2, 3, 4, 5,
6. The number of sides, the number of angles, and the number of exterior angles in every polygon, always the same. All right? So if a shape's got 6 sides, how many angles does that have?
All together.
No, well, how many interior angles, sorry?
6.
6. How many exterior angles?
6.
6.
That's my switch.
Yeah, my fault. I didn't state my question correctly. All right, write this down. Here, you might want to write out in front of this. This is the sum of the interior angles. My pen was right. That's how you find the sum of the interior angles. That means all the angles added together. And then this is the formula for the sum of the exterior angles. On the test, I'm going to mess with a bunch of you on the test because I'm going to put problem number 1, and it's going to say find the sum of the interior angles of a hexagon. Then problem number 2 will say find the sum of the interior angles of an octagon. Then problem number 3 will say find the sum of the interior angles of a dodecagon. Then problem number 4 will say find the sum of the exterior angles of a 322gon. And once you use this formula about 3 or 4 times straight in a row, guess where you're going to go back to? That formula. And if I say find the sum of the exterior angles, do you need to plug that into there? No, the exterior angles for any polygon in the world, the sum of the exterior angles is always going to be 360 degrees, no matter what. So if I ask you to find the sum of the exterior angles for a 15gon, what can you tell me? 360. It's always, the sum of the exterior angles is always 360. So what's the sum of the exterior angles for this 322gon here? 360 degrees. Now the sum of the interior angles would be different, and it'd be some great big huge number. And I'll get a good laugh if you write that great big huge number down on your paper, because that'll tell me you did the wrong formula. On the sum of the interior angles, in here stands for the number of sides. All you're going to do every time is plug in the number of sides right there. Let's do one that we know, a triangle. How many sides does a triangle have?
3.
So we put in 3 right there. 3 minus 2 times 180. What is 3 minus 2? 1 times 180 is what? What do you know about the 3 angles of any triangle in the world? They add up to 180. 4-sided figure. We plug in 4 right there. 4 minus 2 times 180. What is 4 minus 2? 2 times 180? So no matter what 4-sided figure I draw, it's terrible 4-sided figure. It's supposed to be 4-sided, it's supposed to be straight. What do you know about those 4 angles inside there? They add up to 360. What do you know about the angles outside? They add up 360 also. That's the only shape that works for, where both the interior and exterior are the same sum. Now this, again, these 2 formulas, actually this isn't really a formula, right? It's just an answer. But these are both for sums. And you're finding the total of the interior angles or the total of the exterior angles. The next 2, these 2 are for each. All right, again, a regular polygon, got to remember this. A lot of you didn't remember it. Regular polygon is a polygon where all the sides are congruent and all the angles are congruent. So all the sides are exactly the same, all the angles are exactly the same. If we go back to this poster over here, every one of these is a regular polygon except for which one?
Triangle. Wait, JK. Quadrilateral.
The quadrilateral's not. What shape should they put on there?
Square.
They should have put a square on there.
But
And that rectangle is all the sides equal. All right, this is each interior angle and each exterior angle. So you're finding each angle separately. My pen won't write. Looks like I don't know how to spell. Did you see this formula before? It's on the last slide, wasn't it? All we did here, we found the sum of the interior angles and then did what? Divided by n, the number of sides. That's all you're going to do. You've seen 360 before. All you do here, you find the sum of the exterior angles, which is always 360, and you divide by the number of sides. And if the polygons are regular, then that tells you what each of those angles are. If I draw a pentagon up here, got those 5. What can you tell me about this interior angle and that exterior angle right there? They have to add up to equal 180 every time, so that might be something useful also as we go through this. Each interior angle, each exterior angle always have to add up to be 180. And that's not just for regular shapes, that's for any polygon. If you pick one vertex, the interior angle and the exterior angle at that vertex has to add up to equal 180. Give you another minute or so, make sure you got that down. On the next slide, we're going to draw a chart, and we'll go through how to use those formulas, using those formulas. On this chart, write sides down. You don't have to make the chart look pretty like mine, just write sides down. Should you be able to fill in the name for every one of these? So let's go ahead and do that real quick. You write 3, 4, 5, 6, 7, 8, 9, 10, just make a list there. The name, what's the name of a 3-sided figure? Try. It's been a while since I recorded it. We're getting this thing is. Triangle. Yep. What's a 4-sided figure? Quadrilateral. And you can fill all these in, right? I'm just going to go ahead and fill them in. Quit asking you. You can fill them in. 5-sided pentagon, 6-sided hexagon, 7-sided. I'm going to write septagon. The other name is what? Heptagon. 8-sided octagon. 9-sided nonagon. 10-sided is a decagon. Notice I skipped 11 here because we don't have a special name for 11. Does anybody remember what a, right, it's an 11gon. Does anybody remember what a 12-sided is? Dodecagon, very good. How about an n-sided? N-gon. Now to find the sum of the interior angles. Triangle, you already know what's the angles inside a triangle, got to add up to be 180. 360 for a quadrilateral. Now for a pentagon, hexagon, for the rest of these, I'm going to write this up here, and we'll only do a couple of them. Hopefully after a couple, you'll see the pattern. Make sure you got your calculator out. It can be real helpful. Make it go a little quicker. What's 5 minus 2? We plug in 5 for n. That's 3 times 180 is 540. Next one you plug in 6, so you do 6 minus 2 times 180, 720. Next one is 7, 7 minus 2 times 180. Is everybody seeing what I'm doing here? I'm just plugging the number of sides into that formula, n minus 2 times 180. Chloe, that make any sense? What is it, 900?
Yeah.
I'm going to stop here in a second. 8 minus 2 times 180. The next one's going to be 9 minus 2 times 180, right? What are you doing each time? Adding 180. 1440. Now you got to be careful here because we were adding 180, but now we skipped one, right? So 12 minus 2 times 180, 1800. And on the bottom down here, we're just going to put the formula, n minus 2 times 180. That's how you find, no matter what the number of sides is, n minus 2 times 180. Next one, this is hard. So, Shreese, just listen closely, Shreese, because this will probably confuse you. The sum of the exterior angles. Even when I get down to the bottom. Sure, she's gonna go home and tell your mommy and daddy that I was messing with you. Have them watch the video and then they'll come in here and be all mad at me.
Wait, you video this?
Why do you think you record? Don't bother.
My head's gonna
Why do you
explode.
think people need to record?
Wow.
It's like just had an area.
What do you put down on the bottom, even for an insided one? 360 still, it doesn't matter what shape it is.
What time do we get out of here? Like, in a minute? No.
Yeah, we got like
We have like 3
minutes.
minutes left. Jeez.
Each interior angle, that's why we gotta hurry. Each interior angle, if it's regular, all you're gonna do is go back over here to that column and divide that answer by the number of sides. So 180 divided by 3 gives you what?
60.
So each interior angle of a regular triangle has to be 60 degrees. 360 divided by 4 is what? 540 divided by 5 is
108.
108. This is each angle if the shape. So up here, if we look at this pentagon, every one of those angles is 108 degrees. Hexagon, what is it?
120.
120. Septagon,
120.
keep going. 5714 doesn't come out all nice and even, does it? Any idea why we don't use septagons very often? Everything else comes out all nice and even, it doesn't. 135 for the next one. 140. Decagon, 1440 divided by 10. 144. Dodecagon, 150 degrees. So every interior angle for a dodecagon is 150 degrees. What's happening each time? It's getting bigger. What's it going to keep getting closer and closer to? Not 360, 180, because once it gets to 180, it's going to have to stop, because then it's not going to be a polygon anymore. Down here, it's just going to be n minus 2 times 180 divided by n for any n-gon. Each regular polygon, you take the 360, and this time you divide the 360 by 3. What do you get? Take 360, take the exterior angles, divide them by the number of sides. 120, right? Take 360, divide by 4, 90. Take 360, divide by 5, 72. Anybody noticing anything here? They're always what with these two? They always add up to be how much? 180. So this one has to be 60. This one's going to be something like 51 point something something. 45, 40, 36, 30. And this last one's just 360 divided by n. As you walk out, why don't you just keep it? As you walk out, grab this worksheet. That's your homework. Make sure also you got the quiz off Moodle and the vocab. Can everybody remember all that over break? Grab the worksheet.